Welcome to this class. In this short video, we are going to demonstrate derivation of equation of an ellipse. So we start by defining what I mean by the term ellipse. So definition. So an ellipse is one type of a conic section, which is defined as. So an ellipse is a set of all points in the plane such that the distance, the sum of distances from the two fixed points called foci is a positive constant. So this is the definition of an ellipse. It's from this definition that we are going to derive the equation. So the key terms in this definition is sum of distance from two fixed points called foci is a constant. So before we derive, let's draw a sketch of an ellipse. So sketch. So we have this. So this is what we call horizontal ellipse. So we have this, and then there's this line. So this line, this is what we call the center. And then if we call this point V2, this other endpoint, call it V1. So V2 and V1 are collectively called the vertices. And then we have a point here and another point here. So call this one F2, call this one F1. So these points F1 and F2 are what are called foci. One is called focus. And then this line, the line, if you call this point B1, and then you call this other point B2, then B1 is called, this one is called covertex. So similar, this one is also called covertex. This one is a vertex. This is also another vertex. This point here. And then the line joining the two vertices, V1 and V2, is called major axis. So the line segment V1, V2 is called major axis. And then the line joining the co-vertices, B1, B2, is called minor axis. And then if you have a line passing through the foci and perpendicular to the major axis, then that line is called latus rectum. And then this is also another latus rectum. And then the point whereby the line joining the vertices or the minor axis meets the major axis is called the center. And usually the distance from the center to the foci F1, focus F1, the same as distance from center to F2. Similarly, the distance from center to V1 is the same as distance from center to V2. So we are saying that from definition, if you pick any point on this curve, call it P, X, Y, then if you measure the distance from F2, and then you add to the distance from that point to F1, then you always get a constant, which is positive. So let's start by deriving the equation of an ellipse whose major axis is along the x-axis and the center is at the origin. So derivation of equation of an ellipse centered at the origin and major axis on the x-axis. So we'll call this one case 1 or case A. So consider the ellipse given below. So we have this at the y-axis, this at the x-axis, and this is the center of our ellipse, so call it O. And let's have this as our ellipse. So then this is V2, this is V1. Identify the point here, call it F1, another one called here F2. And let's pick a general point on this curve, call it P x comma y. And so we can join this F2 to P and F1 to P. So customarily, the distance from center to vertex is given by A units. And then distance from center to a focus is given small c units. So that's the convention we use. So by that convention, coordinates of point F1 will be c comma 0, because from this to this is c units. Here we'll have a comma 0, and then here we'll have minus c comma 0, because now it's c to the left, and here we'll have minus a comma 0. So that's what we have. And then from definition, distance from P to V2, when you add it to distance from P, not V2, to F2, so those are the foci. So P to F2, and then P to F1, should give us a constant. This is how we define an ellipse: the set of all points in the plane whose sum of distance from two fixed points is a constant. So the question will be, how do we find this constant? So we can say, without loss of generality, let this P be this point V1. That one is correct because V1 is still a point on the curve. So I can say, because I already know the coordinates of V1, so let me take that one to be this general point P. So if I put into this formula, I'll have P V1 plus, V1 F2. So other P, I put V1, so V1 F2 plus V1 F1. And if you go to this diagram, V1 F2, so from this point to this point is this 0 from the origin to this one A units, from this one to this one C units. So that distance will be C plus A. So remember, the reason why this negative just to the left, but then the units from the center to this point is C units. And then V1 F1, from here to here, I simply count distance from the origin to this point, which is A. I subtract distance from the origin to this point, which is C. So therefore, it will be A minus C. And this will be C plus A minus C. And this gives me 2A. So therefore, this constant in the formula is given by 2A. So the formula is PF2 plus PF1 should give us 2A. So that's the constant we are talking about in the definition. So we know that the coordinates of P from the diagram is xy. Coordinates of point F2 from this diagram are given by minus C0. Coordinates of F1 are given by C0. So using distance formula, we have call this one equation 1. We have from equation 1. So distance from P to F2 will be the square root of x minus C, so it will be plus C squared plus y minus 0 squared plus distance from P to F1 will be a square root of x minus C squared plus y minus 0 squared. This will give us 2a. So this is just how we find distance between 2 points, these expressions here. So to simplify this expression or to move the square root sign, we take this term to the right-hand side. So we say square root x plus C squared plus y squared equals to 2a minus square root x minus C squared plus y squared. And then if we square both sides, now we remove one of the square root sign in this equation. So say squaring both sides. We get. So this will give us, remember when I have a square of a number a, if I square a square of square root of a is simply given by a. So this one will just give me x plus C squared plus y squared equals to, now we are squaring this part here. We said we are squaring both sides. So this is what we are doing. So here it's like I have a minus b squared, which is given by a squared plus b squared minus 2ab. So I take my a to be 2a, my b to be the square root of this quantity here. So when I square this one, I get 4a squared. When I square this one, I just get what is in the square root sign. And then twice this product. So 2 times 2a is 4a, so minus 4a, then square root of this quantity. Then opening brackets here, so we have x squared plus c squared plus 2cx plus y squared equals to 4a squared plus, open this, x squared plus c squared minus 2cx plus y squared minus 4a square root x minus c squared plus y squared. So x squared and x squared cancels. C squared and c squared cancels. And then y squared and y squared cancels. So that now I'll have 2cx. And then I bring this one will be now plus 2cx. And bring this one to the left, minus 4a squared equals to minus 4a square root x minus c squared plus y squared. So this will give me 4cx minus 4a squared equals to minus 4a square root of x minus c squared plus y squared. So 4 is common, so I can divide through by 4. I get divide here by 4, by 4, divide this term by 4, so that this 4 cancels, this and this cancels, this and this cancels. So the next step will be cx minus a squared equals to minus a square root of x minus c squared plus y squared. And then I square both sides. So squaring both sides, I'll have the square of this and the square of this. So when I square now, I'll have positive sign. I remember a b power n is a power n, b power n. So which means the square affects both this a and this square root term. So that I have c squared x squared plus the square of this is a power 4, and then minus 2c a squared x. So this, so when you open this, and this, the square of this will be a squared into x minus c squared plus y squared. So remember, the square of a square root is just the number that is inside the square root. So that's why I have this. So I'll have c squared x squared plus a power 4, and then minus 2c a squared x equals to a squared into x squared, opening this, c squared minus 2cx plus y squared. And then open the brackets. So we have c squared x squared plus a power 4 minus 2c a squared x equals to a squared x squared plus a squared c squared minus 2c a squared x, and then plus a squared y squared. Just multiplying a squared by every term here. And in this operation, you see that this term and this term are the same and have the same signs, so they cancel out. So that we have c squared x squared plus a power 4 equals to a squared x squared plus a squared c squared plus a squared y squared. Now what you do next, you take all the terms. So all the terms involving x on one, x and y on one side, and then those involving just constants a and c on one side. So this is what I can do. I take this one to the right, this one to the right, and then I bring this term to the left, this term here, so that I'll have a squared x squared minus c squared x squared plus a squared y squared equals to a power 4 and then minus a squared c squared. Remember what I've just done here is this side I bring c squared x squared to this side, so that I'll have now a squared x squared minus c squared x squared plus a squared c squared plus a squared y squared. And then next, I take this term to the other side. So that's why I have negative sign here. So common here is x squared. So I can say a squared minus c squared x squared plus a squared y squared equals to, common here is a squared. So a squared into a squared minus c squared. And remember, the a squared minus c squared is a positive value because you see from this diagram, a from this center to this point here, this distance is larger than distance from here to here. So a is greater than c. And so when I say a squared is greater than c squared, and so a squared minus c squared must be greater than 0. So this is a positive quantity, and it's the difference of two squares. So I can let that one to be another value, and to ensure that that value fixing for a squared minus b squared is positive, then I make it square. So let b squared be given by a squared minus c squared. The reason that's why I say b squared is to ensure that, remember, the square of any number is always positive. So since the square of a minus the square of c is positive, then if we have to fix it, then to be sure that what we're fixing is a positive value, then it must be a square. So that's why we have b squared assumed to be the place of a squared minus c squared. So from that one, we'll get b squared x squared plus a squared y squared equals to a squared b squared. And since a is greater than b, and both a and b are not 0, then the product of the squares is also not 0, and therefore we can divide through by a squared b squared. So dividing through by a squared b squared, a squared b squared, a squared b squared, then we'll get that this and this cancels, this and this cancels. Here 1, here 1, so 1, 1, 1, 1. So that finally we end up with x squared over a squared plus y squared over b squared. This equals to 1. So this is the equation of that given horizontal ellipse. So this is the equation. Of a horizontal ellipse centered at origin. So the next session will now be discussing about derivation of the vertical ellipse, whereby the major axis is along the y axis and the center remains to be the origin. So thank you.